Hello and welcome back to another video. In this problem, we're told that an airplane is flying at a speed of 350 miles an hour at an altitude of 1 mile and passes directly over a radar station at time t is equal to 0. So in part A, we're asked to express the horizontal distance, d, in miles that the plane has flown as a function of t. So first, let's just draw a little diagram here. So we have our radar station, and we have an airplane flying up above it at a speed of 350 miles an hour. And we have a distance of 1 mile between the airplane and the ground. So the horizontal distance d that the plane has flown as a function of t, so d of t, well, the rate of change of the distance is constant, right? Because the plane is flying 350 miles an hour. That is the constant rate of change. Excuse me. Therefore, this is a linear function. Therefore, we can write it in slope-intercept form. How are we going to do that? Well, we have our variable t. We multiply it by the slope. The slope is the rate of change, which again, we are increasing 350 miles per hour, so our slope, our rate of change, is 350. This is plus the d-intercept. This is d when t is equal to 0. Well, the plane has flown 0 miles at time is equal to 0. Therefore, we are just adding 0. And 350t plus 0 is just 350t, so we can just leave it like that. In part D, we're asked to express the distance f between the plane and the radar station as a function of d. So this is s of d. What is this? Well, if this is the distance d that the plane has flown at some particular time, then this hypotenuse, because this is a right angle, is the distance between the plane at any given point and the radar station. Let's call this, what do we have it as? S is what they're using. We can use the Pythagorean theorem because it's a right triangle. 1 squared plus d squared equals s squared, taking a square root of both sides. The square root of s squared is just s, since it's a positive value. And we can have on this side 1 plus d squared within the square root. S of d is therefore equal to the square root of 1 plus d squared. Now, in part C, we're asked to use composition to express s as a function of t. So if we're taking s of d of t, this is a composition that is going to give you s, the outermost function, as a function of the innermost variable t. Therefore, we have s of, what is d of t? Well, it's 350t. Therefore, we can plug in 350t into d squared. Therefore, we have 1 plus 350t squared. This is 1 plus 350 squared is, I believe, 112500 times t squared, which is just t squared. So this function right here is the distance between the plane and the radar station as a function of time, done by a composition of these two previous functions.